Linear and nonlinear functions, lesson 14 notes. When given a table of values for a function, you can determine whether the function is linear or nonlinear by comparing the ratio of the change in y values to the change in x values. I'm going to stop there. So we're going to compare the ratio of the change in y values to the change in x values. Okay, well first let's talk about the word ratio. You learned that there are different ways to write a ratio. You could write a ratio using the word to, like if you were comparing boys to girls. You could write a ratio using a colon. But the way we write a ratio the most is by writing it like a fraction. Okay? Well, if you had a fraction and you're comparing the change in y values, so you're subtracting y values, over the change in x values, subtracting x values, what would that be? Where might we have seen this before? That would be slope. Change in y over the change in x is the same thing as slope. So in other words, we are going to find the slope between each ordered pair. If the slopes are the same, so if this ratio is the same, if the slopes are the same for all pairs of ordered pairs in the table, it has to be the same the whole way throughout. If it's the same for all, then it is linear. So underline same for all pairs, and then linear. So draw an arrow down to that. But if it's not the same, it has to be the same the whole way down. If it's not the same, then it's nonlinear. Okay, so let's try this. Is the function, example number 3, is the function represented by the values in the table linear or nonlinear? Well, first of all, think of it as y2 minus y1. So we are going to subtract starting from the bottom and go upward. We're going to subtract starting from the bottom and go upward. In other words, I'm going to subtract the 17 minus 2 first. So 17 minus 2 is 15. 2 minus negative 1. Be careful when doing this. It's 2 minus negative 1. That would be 3 because it becomes 2 plus 1. Negative 1 minus negative 7 would be negative 1 plus 7, so that would be 6. Negative 7 minus negative 16. Please be careful when entering this into your calculator. You're subtracting, but then you also need to put it in a negative if it's negative. So it'd be negative 7 minus negative 16, which then becomes negative 7 plus 16, which is 9. Now I'm going to do the same thing on the other side. I'm going to start from the bottom, and I'm going to subtract upward. 6 minus 1 is 5. 1 minus 0 is 1. 0 minus negative 2. In other words, 0 plus 2 is 2. And then negative 2 minus negative 5. Minus negative 5 would become plus 5. So this would be 3. Okay, so now we need to write these ratios. All right, what I mean is I'm going to put remember, it's the ratio of the change in y over the change in x. So those are the numbers I'm going to put together. Then those, and then last those. So the y over change in y over change in x. Change in y over change in x. Change in y over change in x. And then last, change in y over change in x. If you need to, you could point arrows so you understand where you got each of these numbers from. I know it's not as easy when you don't have the highlighter like I do. Okay, so divide these out. 9 divided by 3 is 3. 6 divided by 2 is 3. 3 divided by 1 is 3. 15 divided by 5 is 3. So when we found the ratio, for all these ordered pairs, the ratio of the change in y values over the change in x values, were they all the same? Yes, they were. So all the ratios or the slopes are equivalent. Because all the ratios are the same, it's a linear function. Because they were all 3, it is a linear function. Pause your video, make sure you have all of that written down. All right, that's it for example 3. If you have any questions, please let me know.